Now we have something in a little different format, don't we? Again, this is really harder to graph because you would have to like pick 2 points and all that. Remember, I always want things in the form y equals mx plus b. I'm going to subtract 2x from both sides, and I get minus 3y, these cancel, equals minus 2x minus 6. And then I have to divide both sides by -3. And I just divide each piece by -3. What that does is cancels the -3 with the -3, and I have y equals, and then I have a negative over a negative, which is really the same as a positive x. And then we have minus 6 over minus 3, which is plus 2. If I solve for y, I now have it in the form that I know exactly how to graph. I can come over here and I really like just taking the y-intercept because it's 2. I know this is point when x equals 0, y equals 2. And then I have a slope of positive 2/3. So I go up 1, 2, and I go to the right 1, 2, 3. And that should be my graph. As long as I don't make a mistake mathematically, I'll get the right graph. Y equals 5. That's the same as saying y equals 0x plus 5, because there's no x. If I multiply x by 0, it really is just disappeared, isn't it? I know now I have a slope of 0, and I have a y-intercept of 5. And I'm not going up any, right? Because if m equals 0, then that equals 0 over any x value. And x is 1, the slope is still 0. Same, right? It doesn't really matter what value I put in for x, does it? X isn't really in the equation at all. I can put another dot anywhere. If the slope is equal to the rise over the run, and we know that it's not rising, then it doesn't really matter what's on the bottom. 0 over anything is still 0. I can pick any number. Let's just look at our original equation, y equals 5. When x equals 0, what does y equal?
5.
When x equals 1, what does y equal? When x equals 1, what does y equal? 5. Y always equals.
Oh, okay. So it's always okay.
Right? It doesn't seem to really matter what x equals. Y is always going to equal 5, isn't it?
Okay.
Find the x and y intercept. The x-intercept happens graphically when the line touches the x-axis. For this problem, where do we touch the x-axis?
-3.
Exactly. And the y-intercept, it looks like -1. The y-intercept graphically is when the line touches the y-axis. And there is actually something more that you need to know, and this is for later. Whenever we want to find the x-intercept, sometimes you have an equation and you want to know what the x-intercept is, and you don't have a graph. You don't have to graph the whole thing. It's always going to be on the x-axis, which means y is always going to be 0, isn't it? You can also say when y equals 0. If you were just given an equation, you plug 0 into y and you'll find the x-intercept. And obviously, when x equals 0, you find the y-intercept, because no matter where I am along this y-axis, x is going to be equal to 0, isn't it? So my y-intercept here, we also said was -1. We have -5y minus 3x equals 15. And we want to know, what's the x-intercept? What did I say to do when we have an x-intercept, when we don't have a graph?
You use 0.
For
The y.
exactly, y equals 0. -5 times 0 is 0. I don't need that. I end up with -3x equals 15. I'll solve for x by dividing both sides by -3, and I get x equals -5. Now I know my y-intercept is -5. And the y-intercept, what did I say about the y-intercept?
You replace the x with 0.
Yes, I get -5y minus 0, because x is 0, equals 15. I divide both sides by -5. These cancel, and I get y equals -3. Graph the line whose x-intercept is 5, and the y-intercept is -4.
So we're going down. Yes.
Find the x and y-intercept, then use them to graph the line. We have 4x minus 5y equals -20.
We can do the y first.
Y-intercept. Whenever I do the y-intercept, what do I know?
X is equal to 0.
We have 4 times 0, which is 0. And that means I have -5y equals -20. Divide both sides by -5. These cancel, and I get y equals 4. I'm going to graph y equals 4 is my y-intercept. Then let's do x-intercept. With x-intercept, I say
Y is equal to 0.
exactly. So I end up with 4x minus 0 equals -20. Divide by 4, and I get x equals -5. I plot the other side of that, and that's my graph. For each line, determine whether the slope is positive, negative, 0, or undefined. What's the first one going to be?
The first one is going to be 0.
Good. The third one is what? If you read it from left to right.
Oh, it looks to me like it was going down.
Which way are you reading, left to right or right to left?
I was actually reading from right to left.
Is that how you read a book?
No, left to right.
Read it the way you would read words on a page.
Okay, so then that means it's positive.
Yes. And
the other one is negative.
Let me explain that other one that we didn't talk about yet. Let's go back to our slope example and using a mountain that we're going to ski down as the example. If I had a mountain that looked like this, and I'm up here and I'm about to ski off of it, what's going to happen?
You're going to tumble over.
That's because this is undefined. It does not have a slope. It has an undefined slope. If I talk about the rise is some y value, but the run, which is the change in x, is 0. Anything over 0 is undefined, does not equal anything.
Undefined, okay.
Undefined. And we know that y equals 0x plus 5. Our slope here is 0, which is y equals 5. But for the undefined, this one would be x equals 1. We just make it x equals some value. What is y when x equals 1?
0.
What else?
It can be any number.
It could be any number. It could be 1, it could be 2, it could be negative. It doesn't really matter. If I plot a point 1, 0, it's right here. 1, 1, 1, 2, 1, 3, 1, -1. And then I have a straight up and down line.